Welcome to Frost and Sullivan's Growth Podcast. In each episode, we take a deeper look at transformative shifts shaping global ecosystems, from industry megatrends and technology innovation to evolving customer expectations. Today, we're exploring RF testing at scale, how adaptive validation is reshaping supplier opportunity, unpacking where the next wave of opportunity is unfolding, and what it means for future-ready businesses. RF testing is moving beyond standalone instruments. One of the most important shifts in radio frequency, or RF testing, is the move from individual instrument performance toward complete system validation. Defense and wireless programs now operate across denser electromagnetic environments, combining radar, electronic warfare, communications, sensing, and software-defined functions. Testing these systems sequentially is becoming less representative of how they operate in real conditions. That is driving demand for wideband, multi-channel environments that combine signal generation, synchronized receivers, real-time processing, and software orchestration. The commercial scale reflects this transition. The industry is projected to expand from USD 349.8 million in 2025 to USD 458.4 million by 2030. But the bigger shift is where testing occurs across the program lifecycle. Validation now extends from development and integration into production acceptance, upgrades, and sustainment. This gives scalable and reconfigurable test architectures a more recurring role. It also changes competitive differentiation. Hardware performance still matters, but software flexibility, automation, synchronization, and integration depth now carry greater weight. System-level validation is creating different supplier positions. This shift is also changing how suppliers compete. Integrated platform providers benefit from broad hardware-software portfolios and lifecycle support. Their strength becomes particularly important when programs require signal generation, analysis, processing, and orchestration within one validation environment. Specialists, however, continue to have defined entry points. Software-defined RF architectures create demand for rapid reconfiguration and automated regression testing. Multichannel electromagnetic spectrum operations, or EMSO, environments create roles around synchronization and real-time processing. Advanced wireless introduces additional requirements for interoperability and multi-node validation. Competitive concentration illustrates the advantage held by broad platforms. Of 32 active competitors in 2025, Keysight Technologies accounted for 40.5% of revenue, followed by Rohde & Schwarz at 26.2% and Emerson National Instruments at 8.6%. Yet scale does not close the field. Specialist participation remains relevant where programs require modular RF capabilities, recording, signal processing, software, or focused interoperability expertise. Defense and commercial wireless convergence expands that opportunity further. Validation requirements across radar, electronic warfare, 5G advanced, 6G, satellite communications, and other high-frequency applications are beginning to overlap. The result is a broader competitive environment where supplier relevance reflects not only instrument capability, but also how effectively that capability participates within larger validation workflows. 3 opportunities are expanding RF testing value. 3 areas show where this transition can create commercial value. The first is system-level EMSO validation for defense modernization. Multi-domain operations and software-defined warfare require test environments capable of recreating dense and contested electromagnetic conditions. Limited multi-channel capacity is creating roles across scalable RF platforms, synchronization, orchestration, and system integration. The second is multi-vendor RF validation for Open RAN, 5G Advanced, and 6G. Disaggregated architectures increase interoperability and multi-node testing requirements, widening participation for modular RF platforms and automation capabilities. The third is advanced RF validation for space, satellite communications, and high-frequency payloads. Greater complexity across space and ground systems is creating demand for payload, antenna, high-frequency RF, and end-to-end validation. Each opportunity represents an estimated USD 100 million to USD 500 million over 5 years, with a 1 to 3 year horizon. Through 2030, RF test infrastructure will continue moving toward adaptive, distributed, and software-led validation. Real-time signal processing, scalable multi-channel orchestration, and lifecycle reconfiguration will carry greater commercial value as defense and wireless requirements converge. The next phase of RF testing will therefore be defined less by individual instruments and more by the ability to validate complete systems as they evolve. That shift is turning validation from a test requirement into a broader source of recurring supplier value. Thanks for joining us on Frost & Sullivan's Growth Podcast. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email transformation.growth@frost.com. We'll be back soon with more to help you stay clear-headed and growth-ready.